Hello, my name is Joseph Jung, and today we will be doing a stop motion on the effects of LeChatelier's principle on Q and K. It's from Big Idea 6, where any bond or intermolecular attraction formed can be broken. These processes are in dynamic competition sensitive to initial conditions and other perturbations. Learning Objective 6.10, or the students are able to connect the LeChatelier's principle to Q and K by explaining the effects of stress on Q and K. Science practice number 1. The students can use representations of models to communicate specific phenomena and solve scientific problems. Application number 1. We will use models of molecules moving due to the stress of equilibrium. And scientific practice 2 is the students can work with explanations and theories. Application number 2 will be used the given theories to explain the effects of pressure, volume, and temperature as an equilibrium. We will also discuss Boyle's law with pressure having an inverse on volume. Science practice number 3. The student is able to connect and relate knowledge across various concepts, scales, and representations in and across domains. And application 3 is we will connect LeChatelier's principle property of gases along with thermodynamics. Some of the key terms include pressure, or the idea of force that moves something in a particular direction, volume, the amount of space something takes, and temperature, the average kinetic energy in a system. Equilibrium is a state in which the forward reaction equals the backward reaction. K is the value of concentration of products over reactants, and K is the value obtained by substituting concentration into K at any time. Let's say we have an example of 2 moles of NH3 is in equilibrium with 1 mole of nitrogen gas and 3 moles of hydrogen gas. If we increase the pressure of the system, the equilibrium will shift to the left because there will be a favoring of less moles. And Q would be less than K because there will be more reactants than the products. If we decrease the pressure, the equilibrium will move to the right because there will be a favorance of higher number of moles. And Q would be greater than K because there will be more products than reactants. Increasing pressure is equal to decreasing volume because of Boyle's law, and Q is less than K. Decreasing pressure is equal to increasing volume, which makes Q greater than K. Some of the terms you need to know to increase temperature is endothermic, or system gains energy, or exothermic, system loses energy. If we use the equation from the last example, if we increase the temperature while it's endothermic, it will move to the right because it will try to resist the heat that has been added. So Q will be greater than K because the products will be greater than the reactants. If we increase temperature if it's exothermic, the system will move to the left because it will try to compensate for the heat it has lost. Q will be less than K because there will be more reactants than the products. This is the opposite is true for if we decrease temperature for if it's endothermic or exothermic. So yeah, thank you for listening to my presentation.